Hi everybody, Bill Sky, the Assembly Guy, and this is another video on file input and output, and today we're going to talk about appending to a file. What does that mean? That means opening the file, moving to the end of the file, and start writing data to the end. Many times you just need to add data to a file, and that's called appending a file. In previous videos, I showed you how to open the file as creating the file, but the problem with that is that when you do that, if the file already exists, it's just overwritten. So we need to have a way to actually open the file, to be able to write to the file at the end and not disturb any of the data first. So we're going to do this in Windows and Linux. So I don't know, before we get started, it might be a good idea for us to go over what you need to know to really understand what it means to append to a file. So I've got a little drawing here, or a little drawing pad, and what I'm going to do is I'm going to draw out what a file might look like. And this is very simplistic, but let's go ahead and do it anyway. So if I get my mouse working. Okay, so let's say that this is a file on disk. It's not going to be a very straight file, but that's okay. So there's my file on disk, and it's got data in it. It doesn't matter. I don't know. I'm just going to put a bunch of X's in that file. And what actually happens when you open a file? If you remember, well, the first thing you want to do is you want to open a file. What does it actually mean when you open a file? When you open a file, the operating system contacts the file system and says, hey, I want access to this file. Here's information as to how I want you to open the file. And then the file system comes back and says, yep, file's open, ready to go. But what actually occurs? Well, there's this thing called a seek pointer, or a file pointer. I'll use that term a lot. And the file pointer is a little pointer that keeps track of where you are in the file. So when you first open a file and you have the file is open for read, let's say, the read pointer is at the very beginning of the file. You haven't read anything yet, you've just opened it. So the read pointer is right there. Let's say you go ahead and you read one byte. You read one of the X's. Well, what happens is the read pointer or the seek pointer now ends up there. Let's say you read two X's at the same time. Well, now the read pointer is there. And let's say you read one more. Now the read pointer is here. So that is kind of like a little tab, a little bookmark that the file system uses to keep track of where it is. And a lot of times you'll hear that terms like lseek or file pointer or something like that, right? And if you've taken C or C++, if you know how to code with that, you know that you can move that file pointer anywhere you want inside the file, and that is the initial feature that you need to be able to do random file I/O, which will be a follow-on video. And by the way, you can do this anywhere. I can actually move my pointer when the file opens first. My pointer will be there automatically. I can then move all the way to here if I want, and then I can move back to here, or I can then move to the very end, which is what we're going to do to append a file, or I can then move it to here. So that's what we mean by random file access. You can move the read pointer anywhere in the file you'd like. Now, to append stuff to a file, you open the file and then you move the read pointer to the end. So that's the second thing you do to append a file. Move to the end. And then number 3, you start writing. Excuse the penmanship. So you start writing to that file to append it, but you have to move that read pointer. So with that said, let's get started. We're going to do this in Linux and Windows. I recommend you watch both of these videos. Let's get coding. All right, here we are on Linux. Let's get our Linux groove on. And what we're going to do is I've got a file out here, a project I should say. And I'm going to go into ASM projects. And I'm going to do this as a 64-bit program. And let's go ahead and write some code. So I'm going to create two strings. I'm going to say string 1 define byte. This is the first part of the string. And then we always want to have the dot length of, because we need that to write it to the file. And what I'm going to do is I'm going to create another one called string2. That I'm going to append to the end of the file. Now the reason I'm doing this is because we're also doing this in 64-bit, which is different than the 32-bit, which is what you saw in the very first file program that I wrote, or video that I did. Okay, so let's go ahead and we're going to need a couple of things. So let's go down to the BSS section and let's create a input file handle. Oh, not define queue, but reserve queue. And let's tab that in. And then let's do an output file handle. Reserve queue 1. And you know something, I don't even know if we're going to need both of these, but I always do it whenever I'm doing file I/O. Okay. So now let's do some coding. We also need a file name. Oh, boy, I'm finding more things. So let's create a file name string. Let's just call this text file.txt. Remember, you always have to zero. What's the word? You always have to zero terminate it. There we go. All right, let's build it. All right, looks good. So now, remember, what do you do to process a file? Well, we're going to first write the first part of the file. We're going to write the first string to the file, close it, then we're going to reopen it to allow us to append to the file. All right? So let's write to the file first. And we have to open it first. So let's go ahead and do that. So number one, create the file. Let's put that as a comment. So we're going to move into RAX85. That's for creating the file. We're going to move into RDI, the address of the file name. So file name. We're going to move into RSI. Let's just make it available for everybody. So we're just going to go ahead and make it 777. And then we're going to do the syscall. Now again, comments are so important. Create the file. Address of the file name string. Access to all. And then we're going to go ahead and then tickle the kernel with that. All right, now we want to make sure it opened okay, so I'm going to compare RAX with 0. And it's either going to be 0 or less than 0 if it didn't open correctly, so I'm going to jump if less than or equal to error opening file. Otherwise, we're going to move into the output file handle, RAX. All right, now we have to create some labels here. So I'm going to create a label called end it all. Just put a no op there. And then I'm going to create another label called error open file. I'll put a no op there, and then we're going to jump to end it all. Now that seems to be kind of redundant, right? Why jump to the next line of code? Well, we might put something in between there. We might put something like another error condition, so it's always good to do that. And then at the very end, I'm just going to say jump to end it all. So if there's no errors, we're just going to jump to the bottom. All right, so that should create the file. Now let's go ahead and close the file. Before we do anything, let's make sure that we're able to close the file okay. So we're going to move into RAX, I believe it's 3, and then move into RDI. The output file handle, and then syscall. So let's just make sure that it builds. And we've got a problem. Error opening file not defined. Oh, so I typed that in wrong, so let's go ahead and put that in there. Okay, it looks like it's not, well, actually, hold on. So move RDA output file handle. It says invalid. Oh, I'm trying to overwrite the address of output file handle. So I have to dereference it. There we go. Love making errors. Always learn from my errors. There we go. Now let's just go ahead and see if it runs. Let's see if it just creates that empty file. And it certainly did. So, empty file, but it did it. The code worked. All right, great. Okay, so now let's write the file. Let's write that string to our file. So to write, so let's go ahead and put our comment, close the file. And then number 2 is write to the file. All right, so let's do that. So to write to a file, I'm going to move into RAX1, right? In RDI, the output file handle. Got to make that a comment. Then we have to specify in RSI the address of the string that we want to write. So, and this can be an integer, whatever, string 1. So we'll call it string 1. Then we have to move to RDX, I believe. And then we're going to do a syscall. Now let's make sure we've got that right. Length of, okay, that looks good. All right, let's build it. Now we already know that it created it. Let's see if it writes it. So now I'm going to run it. Let's display it. Look at that, beautiful. So it wrote that string out. Now how do we actually append to it? Well, the file was created, it was written to, and it was closed. Now we're doing that because we don't want to have to write multiple programs to do that. So what we're going to do now is we want to append to the end of the file. So let's say this is create the file and put some data into it. And now down here, I'm going to say append to the file. So the first thing we have to do is we have to open the file for input and output. And I'm just going to copy all of this code because a lot of it is reusable. Instead of creating the file, we're going to say open the file for input and output. All right. So to open a file for input and output, we're going to move into RAX 2. Not 85, but 2. Let's do a little bit of abbreviation there. We've got the file name. We don't need the 770. In fact, when you open a file, you're not creating it. You don't have to put in the file permissions. But what we are going to do is we're going to put the number 2H. And let me explain what that means. So this is the file open flag. 0 is read only. 1 is write only. 2 is read and write. So that's for both of them. And then you do a syscall. We check RAX for equal to 0. If it's less than or equal to 0, we say error opening file. Otherwise, we put RAX. And this time, let's use input. No, let's use output. Okay. So that's going to open the file for read and write. Now we're not ready to write to it yet, and there's really nothing we can do to test it just yet, because all this is going to do is just rewrite to it. But instead of writing to the file right away, let's change these numbers, we have to position to the end. So after we open it, we position to the end of the file to append it later. So we have to go to the end. So to do that, I'm going to move into RAX8. That means move the position pointer. Then we're going to move to RDI, input file handle. Actually, we called it output file, right? Output file handle. Okay, now this can get a little bit confusing, so let's go slow with this. I'm going to move into RSI 0, and that means move n bytes from what? To where 0 equals beginning, 1 equals current position, 2 equals the end. And then we'll do a syscall. So let's talk a little bit about this. So when you move the read pointer or the write pointer, you're specifying you want to move it from some relative position in the file. Current position means where the read pointer is right now. So if when we open this file in number 1 up there on line 51, when we open that file, the read pointer is going to be at the very beginning. So we don't know how big the file is, so we can't say move 30 bytes from the beginning of the file. Instead, we say move 0 bytes from the end of the file. And what that does is it quickly moves that read pointer or that write pointer, that LSEQ pointer, all the way to the end. Now, the other thing you could do is, let's say if you wanted to write something into the middle of the file, you could have said, 5 bytes from the beginning. That's not going to append it. What that's going to do is it's going to move the write pointer, the LSEQ pointer, and it's just going to start overwriting data that's already in the file. But that's not what we're doing here. What we're doing here is we're trying to append to the file, so we move it 0 bytes from the end. So it moves it all the way to the bottom, to the end of the file. And then we do a syscall. Okay, so once it's moved, I'm going to then do string 2. I'm going to write string 2. That's how easy that was. And then we should just close the file. All right, let's build it. Now, just as a reminder, the contents of the file is this is the first part of the string. That's before we made the append change. Let's run it. And look what we've got now. So now, this is the first part of the string, and this is the second part of the string. So I'd appended it to the end of the file. If I wanted to, I could have done this multiple times. And I'm just going to do that. I'm going to just copy that there. We're going to do 2 of them. And now it's there twice. That second string is there twice. So that's how you append to a file in Linux. It's not too bad. In the comments of the description or in the video itself, I've put all of these register values in there, so it should be very, very easy for you to reproduce this. And the next one we're going to do is we're going to do the same thing, but we're going to do it on Windows. I hope to see you at the next video.